Okay, so for the second part, we are going to apply what we learned to this kind of example, local image process and resolution and adjustment. I'm going to show you how, how we can zoom in or focus on a specific part of the medical imaging. And once we zoom in, you may always find out the resolution is not good enough. That means the elements or the pixels within the zoom-in area is not good enough. So what you can do is you can adjust. You can improve or increase the resolution. Okay, this is something you can do. So let's take the example right here. And I hope all of you may have the homework for the last week. If you didn't, just try to create. Right now, don't do it within the command window. I'm going to ask you to create an M file. And then what you can do is you can, again, key in these codes or commands right here. Okay, I think this is exactly the same thing that we did for the last week. So I'm going to do it with you. I won't pause for too long because we have very limited time. So if I finished, you should finish, okay? So let me do it. I'm going to create a new script, right? New script. So very first things, I'm going to use the DICOM read. But again, I have to emphasize one thing. You need to make sure right now you have switched your current folder to the MI materials underline L3. Again, I just want to emphasize you should do this every single week. I don't want to remind you again. But every single time, if you want to get the materials from the folder that I provided to you, you need to switch the current folder. For this week, you need to switch to the MI materials underline L3, okay? And then you can just key in this code. So again, we are going to read. We're going to read this imaging, maybe the very first one. Okay, you can do this, right? You can see I just simply skip all the command line right here. I mentioned that when a line starts with this %, there's simply some kind of a note for you to read, but this is not the command line, okay? So don't really need to put these things, you don't really need to key in this within the M file. It's kind of the notation for you to read. Even you put it within M file, I think it won't cause any error. Okay, but it won't cause any function, I have to say. So you don't need to spend time on it. So very first things, I can just use DICOM read to import the imaging from this DICOM file. Again, you need to save the M file. So maybe just call it anything you like, okay? Okay, then I'm going to do, or maybe I can run it. Do remember how to run it. Once you finish your M file, how to run it? You can just press the button right here under the editor tab. There is a run button right here. Or simply press the F5 key on your keyboard. Either way is fine, okay? So now you may see something right here. You may ask me, teacher, why you put a semicolon after the command line? What does that mean? Let me do it again. If I remove this semicolon, what would happen? Take a close look. What would happen? You see a lot of things printed out in the command window, right? Okay, let me clean it again. And again, I'm going to put a semicolon right here. So let me do it again. Did you see anything? You only see the file name. This is a file name that I'm doing right now. But you didn't see anything printed out right here. So semicolon, if you put a semicolon in the very end of a command line, it will make MATLAB stop printing anything out. It will save time, I have to say. If you ask MATLAB to print out a matrix like 1,000 by 1,000, it may take 1 second or 2 seconds. It just wastes time, okay? So you can get used to it. Every single time when you finish your command line, if you don't want anything printed out in the command window, just put a semicolon right here. Put a semicolon by the end of the command line. Okay. So now semicolon for you should have two different functions. Within the bracket, semicolon represent change row, right? But if it is not within the bracket, it's simply put. It is simply put by the end of the command line. It simply means do not print out anything. Okay, do remember this. Okay, so once you make everything right, you will see IMG, this variable right here, with a size 512 by 512. And again, pretty similar to what we did in the last week, you can use this function. Again, as I mentioned, you can always help it. You can help image show, right? Now you can see image show is easy. It is a function to display image. And you can simply input the variable that you are going to display. So right here, you can just use the IMG as an input. If I do it right now, I just press the run, what will happen? You will see something ugly, supposedly. It's more like nothing, right? It's more like nothing. But take a very close look. There is something. Can you see the teeth? You can see something, but it's pretty hard to see it, right? It's just in wrong contrast, okay? So what you should do, why we put these empty brackets right here, because when you read through the help document right here, you can see the second input right here. This is the chance, this is an input that you can control the lowest value or highest value that you are going to display. This is the display range. For example, if all the values within this image matrix is between more like the 100 to 1,000, you can simply put 100 and 1,000 right here. Then you can expand the contrast to a very good result. However, if you really don't have the idea about this, you can simply use the empty bracket because image show function will simply find out the minimum value and the maximum value for you. Okay, so what I did, I just put a second input. But do remember, if you are going to give a second input, between inputs, you should always use the comma right here. Okay, so you can see imaging, comma, and empty brackets. Okay, so now run it. You can see the result is pretty different. Now you can see a beautiful imaging with a very good contrast. You can see everything, maybe the brightest one, you can see the dark one. Anyway, you can see it very clearly, okay? So I think everyone should know how to do this. So I'm going to give you just 1 minute. Just key into command line right here. Okay, I can tell that every one of you can do it right. So I'm going to proceed to the next slide. Okay, so now there is one more thing I'd like all of you to add it into your M file. And I want you to input this one in the very beginning of the M file. Okay, so please read through it. It's more like the clear and close all. You know clear, right? Clear is a function that can just delete all the variables within the workspace, right? But now you can see clear and close all. Why I use close? Close is a function that you can try right now. For example, maybe I just run my code. Now you can see there is a figure, right? If I want to close this figure, you may say just press this close button. But no, this is not good enough. If I want to use the command line, you can just key in clear. Clear is for variable, sorry, close. Oh, that means I'm going to close all the figures. Okay, so once I key in this line, what would happen? The window would be closed, right? So clear means I'm going to delete all the variables. For example, right here, you can see this is image, right? You can simply key in clear or close all. I think both fine. Both are fine. You can see clear. Okay. So it's kind of the habit that every single time when you try to run a code, you can simply empty all the variables and close all the figures, so it won't get confused, okay? So right now, I'm going to ask you to just add in one more line. Just put clear, close all as the very first line right here. So it will make sure that every single time when you run this code, it will start from the very, I don't know, it will come back to the null situation. That means you won't get any variables and you won't have any figures on hand. Okay, so this is something that you can try. So do remember, you can simply put in this way, or you can also put in this way. More like clear all, close all. You can put it in 2 lines. It's fine. It's fine. Or simply use clear. It's fine. Because if there is anything after clear, it's simply clear everything, okay, within the workspace. Okay, so try it. You can just do it. But I just want to remind you that if you really want to put 2 command lines together, you can use the semicolon or maybe the comma as the separation, okay? So this is the simple way that you can do. Sometimes if you want your code also clean, also clear the command window for you, you can also put CLC right here. How about this one? CLC, comma, clear, comma, close all. That means everything should disappear, right? You can see everything is gone. And after this line, command window is clean, and workspace is clean, and there's no figure. Then come to the third line, it will import the IMG. Come to the 5th line, it will give you this new figure. Okay, so it's just kind of the order that the variable will do. Okay, let's continue. And then I think this is important, so I'm going to take the control. So the step number 2, I'm going to ask you to extract to get a local region. Now, try to imagine what we practiced in the very first section. We always deal with a 5x5 matrix, right? Right now, you are dealing with an image. But again, I'd like to emphasize that imaging is also a matrix, right? Right now, imaging is a 512 by 512 matrix, right? You can take a look within your workspace right here, right? It is also a matrix. If you just open it, it's just lot of the value within it. It's just a little bit bigger compared to the previous one, 555, right? Okay, so what we are going to do right here, I'm going to ask you, please extract, get this local region. I just try to give you the coordinate using the row and column index system, right? So for this point, it's more like 45 and 170 right here. And for this point, it's more like 200 and 340. So you should be able to get a new matrix. Please name this new matrix as the imaging underscore local. Okay, I want you to create a new variable in this name. You have image right now, but I want you to create a new variable using this name. And this variable should be the matrix containing this area. Okay, so think about this. You should be able to, again, use the image show, but now you are not going to show the image, but you are going to show this image underscore local right here. So you will see another figure. You see this is a figure 1, right? This is figure 2. You will get another figure, okay? So think about this before you jump to the next slide. Next slide, yes, it has the answer. But before you jump to the next slide, I want you to think about this. Based on what you learned, what can you do? You definitely will have something like this one, imaging underline local, and you will have the equal sign. On your right-hand side, it should be imaging, but with something right here. I think this is a hint. And of course, based on the row column index, you should put a comma right here. So here is something for row. here is something for column. So think about this. You want to get this area. Think about this, okay? Okay, let me do you a favor. I can give you more information about the range. The range of the road should start from 45 to, again, 2 is column, 45 to, right here, it should be 200, right? 200. Okay. So you can see this is the row range. So for the column range, it's pretty, I think pretty much like the 170 to, again, column is 2 to 340, right? So now what you should do is simply put this range into this parentheses right here. Okay, I think I make it pretty clear. So what you should do, you can see the code right now. It is pretty like this one. Okay, there's only one thing you should know, that before you use the next image show, do make sure that you put a figure right here. What is the function of figure? Let me show you. I should put it. Okay, let me do it. I can have my imaging local right here. I just want to know the number. So 45 to 200 for row, 170 to 340 for columns, right? And then this is very important. Just take a look right here. If I just simply copy it right here, and I just change the image by image local, what would happen? Let me show you. Take a look. Right here, you may expect that you are going to have two figures, right? But what would happen? You may find out you only get one single figure. And this figure only contains the imaging for the specified local region, right? What happened? Where is my very first figure? I have to say it is overwritten by the second one. That means if you didn't give another figure, the second one will simply just override the first one on the same figure. So this is a reason you can try the figure on the command window. You can help it or simply just key in figure. Every single time when you use the figure, it will open another new figure for you. So before you use the next image show, if you really want to maintain both of it, then you need to use the figure before. So in this way, you may find out that you will have the figure 1 and the figure 2 because it didn't overwrite it. You create a new figure and display this local image. Okay, so do remember the function of the figures. So for next slide, you may find out, please compare what is the difference. The next slide, I add something after the second input. Take a look right here. I added something right here. You can see it's more like the border and the tight. What does that mean? When you look at this figure 2, how do you feel? I can only tell you that there is a huge area. It didn't show any informative image right here. It's just a gray zone right here, gray area right here. I don't like it. I want by imaging, take all the space of the figure. I want it to happen, right? So this line, if you put border tight, that means Mapper will try to stretch this imaging to the border of the figure. Okay, so you can do it. You can just try to add something after the second input. But do remember, you need to give it in a string. So border, okay, and tight. Okay, so you just run it again. you will find out right now there is no border. Okay, if you just make the right size, you can see now you can see it much more clearly, right? Okay, so you don't have the space that wasted by MATLAB. Okay, so this is the reason that we put the border tight right here. Okay, so just try it. Just try it. Make sure that you understand the function of the figure and make sure you understand the meaning for the border tight. Okay, then we will go to the final step. So now you should learn how to extract a local region of the image. And you should be able to create a new figure and use the image show without any gray area surrounding the image. You should make a tight border. Okay, if so far you can follow me, just raise your hand so I know you can understand me. Good, good, okay. Okay, so let's go for next or final step. Now take a look right now. The final step, yes, we do get a local image, right? But you can see the pixel size is pretty huge. That means you can see some, ugly border right here. Because right now you don't have the sufficient number of the pixels. So once you enlarge, you zoom in this imaging, you will clearly see the shape of the pixel. Okay, so what we can do is we can try to use this function, so-called image resize. Again, this is a built-in function of the MATLAB, and you can again help it. So let me help it for you. Image resize. So image resize, again, you can input an image matrix right here, and then a second input should be a scale. If I want to enlarge the pixel number by 2, then for the second input, just simply give 2, okay? So now what you can do is you can use image resize to increase the pixel number. This is so-called image interpolation. Okay? So I'm going to show you the result right here. So now, originally, the imaging underscore local should be the size of 156 by 171. It's just what you looked at, okay? But for the right-hand side, this is the imaging that we recreated using image resize with the factor of 2. Now you can see the matrix size for each dimension would be, twice as the original one. So now it is 312 by 342. Now we take a close look right here. If you enlarge single 1, 2s right here, you can see pixel right here pretty clearly. But for the right-hand side, because you increase the pixel number, for each dimension, you increase 2, right? So 2 by 2, you increase fourfold of the pixel numbers. Now everything looks fine. You cannot easily see the pixel right here. That means you have the sufficient spatial resolution. Okay. So if you want to do this, again, you can create another variable, name it as the imaging underscore interp, which is more like the interpolation, okay? Use the image resize. Again, you should use the image local as the input. Do not use image, because image is the full image, right? I only want to resize the local imaging. So imaging underscore local, and the second input should be 2. Of course, you can try. You can try to key in 3, 4, 5, and 6. Maybe you can try, and you can observe what will happen, okay? Finally, I use another figure to display this interpolated image. Okay. So you can try it later, but I just want to show you the homework right now. Homework is simply like this one. You are going to create a new figure, and then you are going to create a new variable. This variable should be named as the imaging underscore combine. Okay, COMB represent combine. That means this matrix would contain both original local imaging, and for the lower part, it should contain the interpolated interpolated local imaging. So you can see, as we mentioned before, because the factor for the interpolation is 2, right? So you can see the final size would be one-fold 156. Here are two-fold 312. So overall, you have three-fold size of the original size, right? And for the column, it will controlled by the interpolated imaging. And for the upper right corner right here, this is simply just the empty one. So all the value right here should be 0. Should be 0. Okay, so your homework is you are going to create this kind of the variable. You need to store the original local imaging for the upper left corner right here, but the interpolated imaging with the factor of 2 for the lower part. And most importantly, you need to display it in a new figure. Okay? So you may ask, how can I do this? You may think about how to create 0. I just want to give you one hint. You may use this function, so-called zeros. Zeros. Again, you can help it. You can help it. Not only zeros, there are so many different so-called matrix generator. But zeros is something that can help you create zeros array. So I'm going to show you how to use this. For example, you can simply use zeros, maybe 5 by 5. Okay, you may find out it will automatically create zero matrix with the specified dimension, 5 row and 5 columns. Okay, so I'm going to give you the hint that first of all, you should use the zero matrix to create this size. You can just do the simple math right here. Create a zero matrix just like this one, as big as this one. Then you can use the set value. You can use the idea of the set value to put the local imaging in the left upper corner and put the interpolated imaging for the lower corner. Okay, so this is your homework. Once you finished, again, you need to name it following our rule, the English letters first, and then followed by your student number, and you can upload it to the E3 system, okay? So that should be all today. Before you leave the classroom, you still have time to discuss with your study group member. If you have any question, you can also raise your hand, okay?